Welcome to Study Loop.
This is chapter 21, problem number 64. We are asked to calculate the total impedance, the phase angle, and the RMS current in an RLC circuit if the frequency is 10 kilohertz and the RMS potential is 725 volts. The inductance is 28 millihenries and the resistance is 8.7 kilo ohms. And the capacitance is 6,250 picofarads. So let's do the conversions first. 10 kilohertz is 10 times 10 to the power 3 hertz. We're good as far as the RMS potential is concerned. So 0.28 henries, 8.7 kilo ohms is 8,700 ohms, and 6,250 picofarads would be 10 to the power negative 12 farads. Now, the total impedance then is going to be equal to R squared plus XL minus XC squared, because now we have both reactances, right? So XL, as you know, is 2 pi FL, and XC is 1 over 2 pi F, the capacitance. Now, plug everything back in the total impedance equation, then we have R squared plus 2 pi FL minus 1 over 2 pi FC squared. Now R is 8,700 ohms, square that, plus 2 times 3.14 times 10 times 10 to the power of 3 hertz times L 0.28 henries minus 1 over 2 times 3.14 times 10 times 10 to the power of 3 hertz. And one more to add here. Let me add it here. It is the capacitance. So it's 6250 times 10 to the power of negative 12. Still in denominator. I apologize. I ran out of space here. Now we're going to take the square of this, right, under the square root. Then the total impedance is going to be 8,735.5 ohms, if we do everything correctly. All right. Now the second part of the question is asking us to calculate the phase angle. So in order to calculate the phase angle, where we're going to take the inverse tangent, what we have is now we have both reactances, XL minus XC over R, then is going to give us the phase angle. And plug in the equations for XL, 2 pi FL minus 1 over 2 pi FC divided by R. Right. So the inverse of tangent, 2 times 3.14 times 10 times 10 to the power 3 hertz times 0.35 Henry minus 1 over 2 times 3.14 times 10 times 10 to the power 3 hertz times 6,250 times 10 to the power negative 12 farads, divided by this entire term, divided by the resistance is 8,700 ohms, right? So then if we calculate everything correctly, what we're going to find is the angle is negative 5.17 degrees. And lastly, we're asked to calculate the RMS current, which is like the easiest to calculate if you know the total impedance, right? The RMS potential divided by the total impedance. So we had just calculated it to be 8,735.5 ohms. From here, we have the current RMS current to be 8.3 times 10 to the power of negative 2 amps.